Hello, let's continue with some further chemical reactions for carbonyl compounds. Today we'll start talking about testing for aldehydes and ketones. In order to test an aldehyde and to distinguish it from a ketone, we have to depend on the rule that aldehydes, they can be oxidized into carboxylic acid while ketones, they cannot. Okay, this is my golden rule in order to continue all of the video, okay, or all of the concept and testing. Okay, let's start with test number 1. In that test, I will use a reagent. It's called in abbreviation 2,4-DNPH. Okay, it stands for what? This is the structure for 2,4-dinitrophenylhydrazine. Okay, 2,4-dinitro, we have at carbon number 2 and carbon number 4. So this is carbon number 1, 2, 3, and 4. This is 2,4-dinitro. It means this is nitro and this is nitro. And we have what? Phenyl. Which one is phenyl? This is, we call it, this is called phenyl. It's a carbon ring with 6 carbon atoms and it contains a substituent. My substituent here, it's hydrazine. Hydrazine mainly, it's NH2, or we can add it to each other in one structure, N2H4. Okay, this is hydrazine. In order to link that hydrazine to my phenyl, I will remove one of the hydrogen atoms and link it to that structure. Okay, this reagent, if we react it with aldehyde or ketone, we will get deep orange precipitate. Okay, deep orange precipitate, it comes from the formation of 2,4-dinitrophenylhydrazone. Let's see the structure for my deep orange precipitate. This is the structure. Type. What's the reaction? This is 2,4-dinitrophenylhydrazine. It will react. Here we have an aldehyde. It's ethanol. I will take 2 hydrogen atoms from one of the hydrogen atoms in hydrazine group, and I'll take what? An oxygen from the carbonyl group. In order to form what? I will form H2O. A type of reaction that will join 2 molecules to each other by eliminating H2O molecule, we call it condensation reaction. So that type of testing, it's called, or it's a type of condensation reaction. Okay, so by removal of this 2 hydrogen atoms and this oxygen, I will link that nitrogen in a double bond to my carbon atom. This is the linkage. Okay, the linkage here, you see here we have alkyl group, hydrogen atom, carbon, double bond, nitrogen with nitrogen. Mainly that is the structure for hydrazone. So hydrazone is what? It's nitrogen connected to other nitrogen, and that nitrogen will be connected or bonded in a double bond to carbon, and that carbon, it contains 2 alkyl groups. One of the alkyl groups, it could be what? It could be a hydrogen atom if we are reacting it with an aldehyde. Okay, if we have a ketone reaction, the ketone, it contains 2 alkyl groups in order to be a ketone. Okay, so mainly in order to have hydrazone structure, it's N, and this N, it's connected to it's NH2. It's NH2. Here we have connected the nitrogen to a phenyl with dinitro. So we will call it 2,4-dinitrophenyl, 2,4-dinitrophenylhydrazone. All the time I will call it hydrazone, and this it has deep orange color. Okay, that deep orange color, if we perform that reaction for So the formation for that deep orange color, it means we have an aldehyde or ketone. How can I distinguish between the aldehyde from ketone? We can purify that precipitate. It's a precipitate here. So we can purify it using recrystallization, and we can measure the melting point for those crystals by measuring experimentally the melting point. I can refer it to its aldehyde or ketone. Okay, so by this I can distinguish the type or this precipitate it belongs for which type or of aldehyde or ketone. Okay, in that type of tests we cannot use it in order to test what carbonyl compounds other than aldehyde and ketones as carboxylic acid and esters. It will not form any precipitate. Okay, this is test number 1, and we'll continue with other tests in a short. Thank you.